We are now recording. Again, you have to find the equivalent resistance. Excuse me. So, the current does this. I'll put a little star here. That's where the current splits. So it keeps going. But then you have another split. Because some is going to go down this way. And some can keep going that way. So current's going to get even smaller off to the far left. So we need to actually start combining this and kind of make this a little more organized for us. So there's a lot of different things we're going to do here. So first off, R2 and R5 are parallel. So you need to combine them. Which will be 1 over 1004 plus 1 over 100,900. Why did I write 100,900? So Kate, I haven't called you yet. Why did I write 100,900? Because I see 100.9 next to R5.
Because it has the like K in front of it.
Exactly, right. And then of course you have to use a calculator. So it's going to be a super small fraction, right? So the combination of 2 and 5, super small fraction. So it's 1 over 1004 plus 1 over 100,900. So I get 0.001005967. And all you have to do when you get R25 is to flip over that number. So it's going to be 1 over that super crazy decimal. Remember, it's just algebra we're doing here. So, like for example, if 1 over x equals 2, x is 1/2. Because that's true. 1 divided by 1/2 is 2. So that's all you're doing. You're just flipping over stuff. So don't make that seem more complicated than it should be. But having a graphic calculator, but you know, you could probably pull this off in a cell phone if you have, you know, the scientific calculator feature. So I get about 994.108. So that's just combining these two. I still have more to do, but at least for now, that's what I'm going to have, 994.108. So now I'm going to clear. Before I clear, let me redraw the circuit. I'll redraw it down below. So we're going to actually redraw the circuit a few times. So again, you have a 3-volt source. This is R1 right here. This is R4 right there. This is R3. And that's R25 combined. That's my new circuit right now. Let me go ahead and clear this other junk. Well, it's not junk, but 994.108. Okay, so remember, that was 994.108 ohms. Now, next up, remember, we were way over here. We've now kind of taken care of all this. Now I need to combine it with this stuff in series. So R3 and R25 are in series because the current just flows through both of them equally. So that's easy. So I'll call this R235. It's simply R3 plus R25. That's an easy one. That's 5.17, or we'll do 5,170 ohms plus 994.108 ohms. So if I add that up, I should get 6,164.108 ohms. I do see there's someone in the chat. Yes, let me explain series again. So series is when the current is uninterrupted. Put it that way. The current is uninterrupted. So let me actually get a highlighter out. That might help. So here is the current right now. Then it breaks apart. Breaks down this way and breaks down this way. When it breaks down this way, there's no interruption for R3 and R25. That's why that's series. There's no interruption. Actually, what I could do is I could do different colors. So it breaks apart again. So it goes down R4, but here it does that. So R3 and R25 have the same current. There's no interruption. That's what makes a series. So series is when there's no interruption with the currents. That's how you know. Hopefully that cleared it up. Okay, why is R4 and R1? They will be. We just haven't got there yet. I really need to go work my way from left to right and really simplify it first. They will be, but we're not ready to combine it yet because R4 is going to be parallel to the combination of 2, 3, 5. So we'll get there, but we're not there yet. But R1, R4 are in series. Yes, they are. Well, technically, R1 is in series with the combination of 2, 3, 4, 5. So let's keep moving. So again, we look at things that are all the way off to the left from the power source, which are R2 and R5. Those are in parallel. We combine that. Then the combination of 2, 5 with 3 were in series because the current was uninterrupted. So we combined that. So now I'm going to draw the circuit again. So again, we have 6164.108. But let me draw this the new circuit again right here. Let's go black. Here's my power source. That's R1. This is the combination of 2, 3, 5 now. And of course, there's R4 right here. So now R2, 3, 5, and R4 are in parallel. We need to combine that next. Okay. So R235 and R4 are parallel. So in order to combine that, that's going to be a combination of 2, 3, 4, 5. And notice the subscripts kind of help us in identifying which resistor or combination of resistors we're working with. Do my best to try to keep my hand steady here. So it's 1 over 6164.108 plus 1 over 10,900. Let's get that wacky decimal. Okay, let's see here. And add that to 1 over 1090. Okay. So if you do that, you should get 0.00002613374. Raise that to -1 power. And looks like I'm off a little bit from what. No, I'm good. So I get, so remember, R2345 is going to, be the reciprocal of that. So what we could do is do 1 over that number, or raise it to -1 power if you have a scientific calculator or a graphing calculator. Because the same thing, when you raise it to -1 power, you do 1 over that number. And I do get 3,826. I could do right there on that. 3,826.471. So that's a combination of 2, 3, 4, 5. So now my circuit is going to look like this. I'll do it down here. So I've simplified the circuit quite a bit now. So I have my 3 voltage source. This right here is 2, 3, 4, 5, all combined now. And that right there is R1. Now that's in series. So someone had asked earlier, weren't R1, R4 in series? Kind of, but the problem is that this right here and this right here, this is going to be impacted, R4, but all this stuff to the left of it. So we need to make sure that we work away from left to right, combine the resistors properly to get the right resistance for this over here, which will be in series with R1. So now I'm ready to finish off this problem. Okay, let's keep going here. So final step. R2, 3, 4, 5, and R1 are in series. So that means that the whole thing, R1, 2, 3, 4, 5, equals R1 plus R2, 3, 4, 5. R1's 101 ohms. And remember, we had 3,826.471. Add 101 to that. 3,927.471 ohms. And that's going to be your equivalent resistance. Bit labor intensive, but it's just kind of good to help you guys be meticulous with your work, because that's what a good scientist has to be. You have to be meticulous. Yes, there are technology solutions that can do this for you more quickly. I'm sure you could do a quick search on the web and find something how to, circuit calculator. I don't know, sure, I'm just making that up, but maybe there's something called circuit calculator. I have no idea. So let's have you guys try some problems. Let's see here. I think 9's kind of a good one. You have to kind of think a little bit outside the box here for 9, but I do like 9 a lot. And let me think here. We're not ready to do 10 just yet. We can come back to that one. I think we could do 12. Let me just read 12 really quickly here. No, I won't do 12 yet either. But maybe 14. I say let's just do 9. I think that's good. So actually, why don't you guys we don't have to go to breakout rooms for this. So I'll stop the recording.